Okay, so the next topic is intervals and interval notation. So we will know that what are intervals and how to write an interval, what is the notation to write the interval. So real values and intervals. A function is defined as a real function if both the domain and the range are sets of real numbers. A function is called a real function if the domain of the function is real numbers and the range of the function is also real numbers. Many of the functions you have likely encountered before are real functions, and many of these have domains is equal to r. For example, the function y is equal to 3x. We can put any value from the real numbers, so domain is real numbers. A section of the graph of this function is shown below. You may already be familiar with the graphs of the line. In particular, you may already be in the habit of placing arrows at the end. Why? We do this in order to indicate that the line will continue forever in both positive and negative directions, both in terms of the domain and the range. The line above, however, only shows the function y is equal to 3x on the interval minus 3 to 3. The square brackets indicate the graph includes the endpoints of the interval. X is equal to minus 3 and 3. Okay, now just listen to me. If I have the graph that is shown in front of you, and on this graph, if I'm going to put the arrows like this, it means graph is going towards the positive direction and negative direction from both x and y axis. So it's going towards the infinity, positive infinity and negative infinity. But here there are no arrows. It means the graph stops somewhere. So let's check where it is stopping. It's stopping at 3 from the x-axis. And it is stopping from -3 from x-axis. It's going +3 towards the positive axis and -3 towards the negative axis. Okay, so 3 is included. So if we have let me give you another example, easy one. Okay, if I have a line, I have 0, 1, 2, -1, -2. And if I would say that my interval includes 0 to 2, so I will write the interval sign like the square brackets 0 to 2. But if my line does not include 0 and 2, but involves all the numbers between them, so I will write 0, 2 with square brackets. Square bracket means the end numbers are not included. 0 and 2 are not included, but all the numbers between 0 and 2 are included. This bracket means that the 0 and 2 are also included and the numbers between 0 and 2 are also included. So this bracket is called open bracket or open interval. This is called closed interval. Closed means the end values are included. Open means the end values are not included. Okay, now I have 0 included, but the 2 is not included. So I will write 0 is included, but 2 is not included. Or 0 is not included and 2 is included. So these both are called semi-open.
Semi-open, okay.
Means one is included and one is not included. So this is what they're trying to explain is, in the next page, there is a table. So if you will look at the table, we have A, B close interval. This bracket means close interval A, B. So interval notation is A, B close interval. If we will write it in the form of inequality, it can be written as the values of the x are between A and B,
including A
and B, and equal to sign means including A and B. So therefore, in inequality notation, we're going to write equal to over here because it's closed bracket and it means they are including. But here it's open bracket and they're not including, so we are not going to write the sign of equal to. Just write greater than this into. Here A is including. A is including means A will have the sign of equal to, but B won't have the sign of equal to. Here B is going to have the sign of equal to, but A won't have the sign of equal to. Here A is going towards a positive infinity, means X is greater than A.
The both are not, okay.
Because X, we don't have any limit where it is stopping. We don't have any B. We don't have any number. It's going towards positive infinity, means X is greater than A, going any number, positive infinity. Now, A infinity with a closed bracket means A is also included and going towards positive infinity. So we will have greater than equal to. Similarly,
why not A less than X? Why greater than?
because it's going towards positive infinity. If it will go towards negative infinity, then less than equal to a or less than a.
Okay.
For positive, you need to write greater than. For negative, you need to write less than.
Okay, got it.
Now, the value of x is between a and b, including a and b. Now, see what are they saying? The value of x is between a and b, including a and b. The value of x is
Okay.
between a and b, but in this bracket, it's not
They're not
including a.
including. Yes.
The value of x is between a and b, including a. It's including a, but not including b. In the
Yes.
next, it's including b, but not including a.
Not A. Yes.
The value of x is strictly greater than 0 because it's going towards positive infinity, greater than or equal to a. Because here it's close bracket. Then strictly less
Yes.
than a or strictly less than or equal to a. So this is all about open brackets and close brackets, open interval and close interval, inequality notations for the open intervals and the close intervals. Okay, earlier you were given a problem about buying tacos for lunch. Together you have $15 to spend on lunch, and tacos are 1.25 each. It is clear that the total cost could be graphed as a function of the number of tacos purchased, but how would you specify that the graph should not include values greater than $15 and less than $3.75? So $15 and $3.75 is included, and so we will use the close brackets.
Yes.
Simple.
0.7.
Sorry, मैं ज़्यादा ऊपर या नीचे चली गई.
Oh. अब काफी नीचे चली गई.
Okay. Identify the sets described. Now, in the first set, the set of numbers are between -3 and 9, not including the value of -3. Because -3 has open. Okay, tell me about this B.
So in दोनों में both -23 and 12 are included.
Okay, and in the C?
In the C, it's going like 0 is not included and it's going towards the negative infinity. Yes.
Sketch the graph of the function f of x is equal to 1/2x minus 6 on the interval -4, 12.
So -4 is included, which is x -4, and 12 is not included.
So here it is -4. And here it is 12. And 12. Okay. The figure shows the graph of 1/2x minus 6 on the given interval. All positive numbers. How to write all positive numbers in the form of intervals? Positive numbers this is the number line. Positive numbers will start from 0 and move towards positive infinity.
Yes.
So it would be 0, positive infinity.
Yes.
The numbers between -8 and 242.
-8 and including both. So we will take the square bracket, not the round one. Square bracket -8, and then what is it? 242. And both included, so both will have the square brackets.
All negative numbers 0 and the positive numbers up to and including 9.
All negative numbers, they are included, huh?
Yes.
All negative numbers. So all negative numbers. So it will be -infinity
to 9.
Included.
Including 0, including the numbers till 9. So it's -infinity to 9.
Infinity to 9. Yes.
Describe the domain and range in the sets in the images below using interval notation. So domain is, we already know what is the domain. Domain is the x values. So here it is starting the x value from -6 and the x value is going to -4. Okay, I'm going to tell you one
-4.
that if this circle is colored,
Yes, so it is included. This is
included.
included. Yes, and which is not colored, this is not included.
Not colored means not included. So
Not
it's going
included,
from
yes.
minus 6 is included, and 4 which is not included. The domain.
Yes, the domain, yes.
Okay.
And
Coming to the
y will
range.
be range will be 4 and included, and -3 not included.
Very good. Coming to this graph.
This one is -6 included and 7 not included.
Okay.
And then
Range.
range is -1 included and 6 not included.
Good. Coming to the DB. Okay. Write the following in the interval notation.
Interval notation. Including bracket, I mean square bracket -3 and then 1 not included, and then not included 0 till 2 not included, and sorry.
Yes.
This will be x is greater than -3. So -3 and then infinity. -3 is not included, and then infinity
Infinity is
is
never
not included.
included. Infinity
Never,
is never included.
never included. And less than 2 will be negative infinity, and then 2 is included. This I have already done. Okay, this one is which one? Minus 2x plus 3 is not included, and
First of all, you need to find it.
what I need to find?
You need
X.
to find the value of x first. X is less than 1. So now
S
you can
is
write
less,
it in the interval notation.
S is less than 1 is minus infinity not included, and then -1. Sorry, 1 not included.
Again, in the question number 6, you need to first calculate.
Okay, 7x plus 4 less than 2x minus 6. 7x minus 6 minus 4 less than equal to -2. X is less than equal to -2. So as in less than equal to -2. So -2 included, and then positive infinity not included. Huh? What?
What happened?
So -2 is included.
Yes.
And then how positive infinity? I was going for positive infinity. Why did you write negative infinity?
X was less than or greater than?
X was less than or equal to -2. So
Yes, for less than we will go for negative infinity. For greater than we will go for positive infinity.
okay.
Okay. Fastly tell me the intervals for each of the number line.
Yeah, love के क्या interval is the -3 not included and 0 not included. So -3 and positive infinity.
Okay.
Huh? Okay, I
You
think
need
it's
to
6.
work on the circles.
Okay, inshallah I'll complete it because it's 6 now, right? It's been an hour.
Okay. Okay.
I'll do this inshallah. I'll revise it and I'll
No
finish
problem.
it.
There are only 3 or 1 to 2 questions. I can do it by tomorrow. Yeah.
Okay.
Anyways,